Hi, my name is Bahadur Ahmedov. In this video lecture, we are going to discuss about the points on the rectangular coordinate system. We are going to define the distances between them, and also we're going to see the equations of such curves as the circles. Previously, if you remember, we've just got a number line where we are given the numbers, and the numbers are going to be put on this number line depending on their distances from the origin, from the zero. For example, I can go to the right, so this point is going to be equal to 1, 2, 3, 4, and so on. And if I just go to the left, it's going to be -1, -2, -3, and so on. And if we would like to just find the distance between the 2 points on the number line, for example, the distance between 3 and -2, I just need to subtract them and take the absolute value. So 3 minus -2, and we have to take the absolute value, and this is going to be equal to the 5. This gives us the distances on the number line. So now, if we are going to the rectangular coordinates, now we're going to have two axes, since the points can move in the two directions, like in the x direction and in the y direction. And essentially, you're going to see that we can define the points, any point on this plane, actually. So we call this as xy plane, just using the two coordinates. So the point, let's say, was the coordinates 2, and 2 essentially means that in order to reach this point, you need to go 2 units to the right and 2 units to the above. So then when you reach this 2 and this 2, you need to create the vertical line and the horizontal line, and intersection of these two lines is going to be this point. So let's define another point here. For example, if I would like to define this point, so it was the coordinates -1 and -4. It means that you need to go -4 units to the bottom, down, and -1 unit, or essentially 1 unit to the left. So this is going to be -1 here. And then again, so we're going to make the vertical line, the horizontal line, and this is going to be our point. So in the rectangular coordinate, it is really important for us to define how to find the distances between the 2 points, because it is a little bit more complicated than in the 1D case. But before doing that, I just would like to give you the equations of the vertical lines and the horizontal lines. So you see, so we've just got two axes, and this axis x is going to have the equation y is equal to the 0. Because if you're just going through the points on this x-axis now, all of the points are going to have y coordinate to be equal to the 0. For example, this point R is going to have the coordinates 2 and 0, since it has the x coordinate to be equal to the 2 and y coordinate to be equal to the 0. Or for example, this point, O point, let's say, has the coordinate 1, 2, 3, -3, and 0 again, because it can be reached by going to the left direction -3 units, and it's on the x line, so there is no y. So that is why this axis x sometimes is denoted as a y is equal to the 0, since all the points along this axis have the 0 y coordinates. So similarly, the y-axis can be defined as the line x equal to the 0, since all the points along that line have the x coordinates to be equal to the 0. For example, let's denote this point as a P1. This point has the coordinates 0 and 2, since you can reach this point just by going 2 units top above the origin. So this point is going to be called as the origin, and origin is going to have the coordinates 0 and 0. Okay, so for example, if you just go to this point, let's say M point, and its coordinates is going to be 0 and -4, 0 and -4. So since it has x coordinate to be equal to 0, and you need to go 4 units down to reach this point. So essentially, all of these points along this axis, y-axis, have the x coordinates to be equal to the 0. So that is why we're just going to denote this as the y is equal, x is equal to the 0. Again, x coordinate is y is equal to the 0, x-axis is a y is equal to the 0, and y-axis is x is equal to the 0. So any line, actually, the vertical line or the horizontal line, can be defined using this kind of equations. As you have already noticed, the system of or the algorithm of denoting them is going to be defined by the y or x coordinates, right? For example, if you would like to denote this line, this vertical line, then what you need to do is that all the vertical lines are going to be x is equal to some constant, right? So in this case, x is equal to the 2 constant. And all the horizontal lines are going to be y is equal to some constant, right? For example, in this case, if you would like to draw this horizontal line, so this is going to be y is equal to the minus 4. You see? So all the horizontal lines are going to be y is equal to the constant, and all the vertical lines are going to be x is equal to some constant. So now let's define how the distance between the 2 points. And before defining the distance between the points, I would like to point an important theorem from geometry called Pythagoras theorem. So there is a theorem called Pythagoras theorem, and it's about the triangles with the right angle. So any triangle has these 3 angles. So I'm just going to draw a triangle. And the sum of its angles should be equal to the 180 degrees. So let's denote this angle as alpha, this was going to be beta, this is going to be gamma. And the sum of the 3 triangles, alpha plus beta plus gamma, should be equal to the 180 degrees. So there is a special type of the triangles where the gamma, one of the angles, is going to be equal to the 90 degrees. Then we're going to denote this angle with a rectangle. So it's going to be 90 degrees, or in terms of the radians, it's going to be equal to pi over 2. Well, for this triangle, there is a theorem which is going to relate the lengths of the 3 sides of this triangle. So if you know the lengths of the 2 smaller sides of this triangle and the lengths of the the longest side, so this is also called the hypotenuse. Hypotenuse. Then we can find, so then the theorem states here that, hey, c in the square is going to be equal to the a in the square plus b in the square. So this is essentially the Pythagoras theorem. So it works for the rectangular triangles. So rectangular triangles or right angle triangles. So the right triangles. Since it has a right angle, right? Good. So let me show you an example. For example, if you're given the triangle with one side is equal to the 4, another side to be equal to the 3, then the third side can be found using this formula. So the c in the square is going to be equal to the a in the square. So let's say a is equal to the 3 plus b in the square. Let's say 4 is equal to the, or b is equal to the 4. If I would just substitute this here, it's going to be c in the square is going to be 3 in the square plus 4 in the square, which is going to be 9 plus 16, which is going to be 25. And if you would find a c, it's going to be equal to the 5, since we need to take the positive part of this point. So since the lengths of the side, the side of the triangle cannot be negative. So this side is going to be equal to the c. We are going to denote this as the c. So in ancient Egypt, people have used this theorem, this equation, in order to build the buildings, because whenever you build the buildings, it is really important to have the right angles, or the angles within 90 degrees. So in ancient Egypt, people knew about this theorem, and used this theorem in roughly 1900 uh, year before the century, so roughly 4,000 years ago. Good. So now we are going to, so in that time, so this theorem was really important because they could build uh, the buildings using this equations. And this theorem is still important nowadays, and we can define the distances between the points using this theorem. So let's define how we can do this. So let's say again, we're given a point on the rectangular coordinates. And I would like to find the distance between a point and the origin. So let's say we're given the rectangular coordinates with the x-axis and the y-axis. And let's say we're given the point. So let's say this point is going to be here, maybe. So this point is going to be P point was the coordinates. So here, I just need to go to down to the x. So this is going to be equal to the 3, right? If I just go to the right, this point is going to be equal to the 4. So this point P has the coordinates 3 and 4, right? So what I would like to do is I would like to find the distance between the origin and this point. So in order to do this, I'm just going to make the triangle. So what I will do is I will just project this point onto this x-axis, and then we'll just connect this point, which is the projection of this point onto the x-axis, and the origin. So I will get a sort of triangle here, right? So we're exactly triangle. And the beauty of this triangle is that I know the lengths of this triangle. So I know that the length of the blue side is equal to the 4 just because I know how I reach this point P, right? So in order to reach this point P, you need to go 3 units to the right and 4 units to the up, and you will reach this point P. It means that I know what is the length of the width, the yellow side of this triangle as well. So the width of this triangle is going to be equal to the 3. Then I can find the distance between the point and the origin easily using the Pythagoras theorem. So the distance, so the Pythagoras theorem tells you that, hey, if you've got a triangle with the right angle, then you can find the third side just using the other two sides, the lengths of the other two sides. So let us write this. So the Pythagoras theorem tells you that, hey, this distance in the square is going to be equal to the 3 in the square plus 4 in the square, which is going to be equal to the 25. So that is why the distance is going to be equal to the 5. So this is how we are going to define the distances between the points and the origin. For example, if you're given another point here, so this point Q with any coordinates x and y, so essentially it doesn't matter what is the x and y. Numerically, we are just going to figure out the formula to this. Then the distance between this point and the origin can be found using the Pythagoras theorem again. So you can just project this point onto the x-axis, then the length of the height of this triangle is going to be equal to the y-coordinate of this point, right? And the width of this triangle, is going to be equal to the x-coordinate, or in the module, right? X-coordinate in the module, or in the absolute value of the x-coordinate of this point. So since you see, so you may go to the left or bottom, right? It's better to take the absolute value. But whenever you're going to square them, this you don't need the absolute value. So then the distance, we're going to denote this as a d between this point Q and the origin is going to be equal to x in the square plus y in the square. Then we have to take the square root, right? So it's distance in the square is equal to x squared plus y squared. So the distance is going to be simply square root of x squared plus y squared. So this is how we can find the distances between the points and the origin. But for us, it would be even more important and useful to figure out the distances between the 2 points, rather than the point and the origin. So, but the idea of finding the distances between the 2 points is going to be very much similar to this one. So let's try to do this. So now let's say on the rectangular coordinates, we are given 2 points. The first point is going to have the coordinates 1 and 1. So the first point is going to have the coordinates 1 and 1. So P point has the coordinates 1 and 1. And the second point has the coordinates 5 and 4. So 1, 2, 3, 4, 5. 1, 2, 3, 4. So this is how we are going to reach the points, right, on the rectangular coordinates. So let's say this is Q point was the coordinates 5 and 4. Very good. So now I would like to figure out how to find the distance between these 2 points. So I would like to find, for example, the length of this line, the white line. So in order to do this, I'm going to use the same idea. So I would like to create the triangle first of all. So I can just project this to here, but not to until the end, but until here, because of the coordinates of this yellow point. So then I can just connect these 2 points in order to create the triangle. So please note that this triangle is always going to have the right angle. So in order to find the lengths of this blue side, I'm going to use the coordinates of the blue point and the yellow point. So now it is not just enough to know the coordinates of one point in order to find the height or the width of the triangle. So we need to use the coordinates of both of the points. So this height is equal to the 4 because of the y coordinates of this point. At the same time, I know what is the height until here, which is going to be equal to 1, which is the y coordinate of this yellow point. So since I know these 2 lengths, I know that then this height should be equal to their subtraction. So it's going to be 4 minus 1. So in general, you need to put the absolute value in order to have the positive value for the height of the triangle always. So this is going to be equal to the 3. So this, in a similar way, we can figure out the width of the triangle. So let's say the the distance from the origin or from the y-axis until here is going to be equal to the 5. The distance from the y-axis until here is going to be equal to the 1. So that is why the width of this triangle is going to be the subtraction, which is going to be 5 minus 1, which is equal to the 4. Then using the Pythagoras theorem again, so we know that this distance d is going to be equal to the square root of 4 in the square plus 3 in the square, which is going to be equal to the 5 again. So how to figure out the distances in general? So did you understand what we did is actually we've got just the subtraction of the x coordinate of the 2 points, right? So essentially x1 minus x0 in the square, plus we've subtracted the y coordinates, y1 minus y0 in the square, then we took the square root. So this is essentially what we did here, right? Good. So in general, if you're just given 2 points, so one point was the coordinates x and y, or x0, y0. Another point was the coordinates x1, y1. Then you can find the distance again using the right angle triangle. So again, so you are going to make the triangle. Then the height of this triangle is going to be y1 minus y0. And the width of this triangle is going to be equal to the x1 minus x0. Then this distance, the line, the length of the line, which connects these 2 points, or line segment, which connects these 2 points, is going to be equal to x1 minus x0 in the square plus y1 minus y0 in the square. Then we have to take the square root. Let's do a small example. So let's say you're given 2 points, 2 and minus 3, and the second point has the coordinates 4 and minus 7, for example. Or let's say minus 4 and 7. Minus 4 and 7. So if I would like to find a distance between these 2 points, I'm going to denote this as a d, p, and q. So this will mean the distance between the p and q is going to be equal to square root of, I need to subtract the x coordinates. It's going to be 2 minus 4 in the square plus minus 3, right? So then the subtraction of the y coordinates, minus 3 and 7. So this is going to be minus 3 and minus 7 in the square. Then I have to sum them and take the square root. It is going to be square root of 2 minus 4 is going to be 6. 6 and the square is 36 plus minus 3 and minus 7 is going to be minus 10, which is 100 in the square. Then we have to take the square root. It is going to be square root of 136. So the distance between these 2 points is going to be equal to the square root of 136. This is how we're going to find the distance between the 2 points. So now let's discuss how we can figure out the equation of the circle. Let's do this in our next video. So we are going to define the equation of the circle just using this formula of the distances.